Thank you very much, everyone, for joining the September edition of Bringing Mind to Market, a LIFT webinar series discussing how we're developing an educated and skilled advanced manufacturing workforce. Today, we're going to be talking about the new Ignite Mastering Manufacturing curriculum that's being developed through LIFT in partnership with other Manufacturing USA institutes and other industry and academic partners. You'll hear from those folks a little later. Wanted to go through a couple of housekeeping items for you before we really get rolling. The first is, please put your phones on mute. The less background noise we have during the presentation, the better everyone will be able to hear. Secondly, this webinar will be recorded, so please, again, another reason for the reduced background noise, this will be posted on the LIFT website towards the end of the week, so stay tuned for that if you wanted to watch it again or share it with folks who were unable to make it. It'll be posted there. Also, if you have a question, please use the chat function that is on the GoToMeeting toolbar on the right side. You can address the question to the organizer. That'll come to me, and I will help facilitate the Q&A when the time comes at the end of the presentation. So you can ask questions throughout. Last time we had Bringing Mind to Market webinar, there was a whole conversation in the chat function. So please use that, and we will do our best to respond and ask those when the time comes. So a little bit about LIFT. We are part of Manufacturing USA, which is a national federally supported institute. In 2014, funded in part by the Department of Defense and managed by the Office of Naval Research. Our mission is simple. We are revolutionizing manufacturing through lightweighting, innovation, and education. We believe that if it moves by land, in the air, on the sea, or in space, it can be lightweighted to move farther, faster, and more efficiently, directly benefiting both the U.S. commercial and defense markets. LIFT is based in Detroit. We are over 200 members and partners across the country in industry, education, and research. We've got more than 600 engineers and researchers and professors and industry experts and economic developers that are part of our network. And we are home to a 100,000 square foot R&D facility that we share with another Manufacturing USA institute, ACME, the Composites Institute. So we are both there in Detroit. Suite of large-scale manufacturing equipment that is ready to be used by large corporations, small and medium-sized enterprises to solve any of your lightweighting needs. And not only do we have the machinery, but we also have the experts, as we mentioned, as part of our network. So please reach out to us at lift.technology. You can also follow us on our social media channels at News from LIFT, and reach out to us anytime at communications@lift.technology. Along with the R&D side of the shop that we have, the other focus that we have as a Manufacturing USA Institute is investing in education and workforce development to ensure that we have a pipeline of talent ready and available to take advantage of these new innovations when they get to the workplace. So to talk a little bit more about that, I'd like to invite Emily DeRocco, our Education Workforce Director, to explain what we have done so far and what we continue to do in the education workforce space. Emily?
Thanks, Joe. Since its founding, LIFT has had a very strong workforce development mission with two important goals. The first, to address the skills gap that manufacturers today are experiencing as they are unable to find the right people with the right skills at the right time. And the second goal has been to align technology and talent development, recognizing that new technologies will not move to market if we don't prepare our current and next generation workforce with the right skills. Now, in our 5th year of operation, we are very much focused on building out a world-class learning lab at our Detroit headquarters. The Learning Lab, which is illustrated in the next slide, thank you, Joe, is going to be a partner to our technology teams and our high bay that hosts $50 million of advanced manufacturing equipment. I hope you'll jump on a webinar coming up within the next few months where the Learning Lab will be deeply described and actually launched and operationalized at LIFT. But meanwhile, back to Ignite. Early in our evolution, the Manufacturing USA Institutes recognized that there was a need to develop what we then called the multi-skilled technician for advanced manufacturing. Manufacturers needed employees with higher level, more integrated skills to bridge between design and production. So in November of 2016, all of the Institute's education and workforce development directors gathered in our training room in LIFT, and we developed the initial competency model for this multi-skilled technician, a summary slide of which you're looking at now. But using that outline of a competency model, LIFT then partnered with America Makes and DMDII in 2017 to compete for available funding under the Department of Defense's Manufacturing Engineering Education Program to develop and initially implement a comprehensive curriculum that would prepare individuals for these critical technician jobs in advanced manufacturing. The result is Ignite, Mastering Manufacturing. You know, there are many points of differentiation of Ignite from other curricula in this space or in this area. I want to just point out what I believe are the most important differentiators before I turn you over to the developers. Ignite recognizes manufacturing begins in the R&D environment, and Ignite students will experience hands-on application of emerging tools, developing technologies, and new processes. Ignite also provides a solid grounding in the material sciences and the properties of materials, preparing students for the work of design, which is the core competency of engineers. Ignite introduces students to new computational tools in manufacturing, critical to both product design and product fabrication. Ignite ensures students are prepared for smart factories that network manufacturing tools and world-class equipment. And finally, Ignite educated technicians and technologists will in fact drive the next generation of advanced manufacturing in the United States. So now I'd like to invite Eileen Pickett, who is managing the Ignite project team for LIFT, to join us and take it from here. Eileen?
Thank you, Emily. I am going to walk through sort of the high level where we are with Ignite, and then invite a couple of our key partners to take us really through the curriculum and what we believe we can achieve with this program. So first thing I'd like to do is just introduce you generally to all of the partners who've been involved in the project since the beginning. The three Manufacturing USA Institutes, LIFT, of course, who is hosting our webinar today, America Makes, which is located outside of, or in Youngstown, Ohio, and DMDII, which is the Digital Manufacturing Institute located in Chicago. Those are the three Manufacturing USA partners. Then our national partners who bring national expertise in their particular areas to the project, Amatrol, who is developing the technical curriculum for us and the online learning, and you will hear a little bit later from Paul Perkins with Amatrol about the work they've done. The ASM Materials Education Foundation, Cleveland, Ohio, and we'll hear from Carrie Wilson, and who will talk particularly about material science and the role of material science in the curriculum, but also about some really excellent teacher development that goes along with the Ignite program. And then the Ohio State University and the PAST Foundation, both in the Columbus, Ohio area, who have developed the material science curriculum, which really kicks off the Ignite curriculum in total. So Emily showed the competency model that was developed now almost 2 years ago in that collaborative meeting in Detroit. as part of this project to develop this curriculum, that competency model has been translated to an educational pathway. So that's what's showing on your screen now. And if you sort of start at the bottom and work your way up, you can see the pieces that are now reflective of an educational pathway as opposed to the competency model. So sort of going to the next step. So a student enrolls and builds to ultimately become that multi-skilled manufacturing technician. So we have the common employability and information technology skills, foundational material science skills, which we'll talk about in just a minute, the core technical skills, then layering on top of that the advanced technical skills, and then finally technology-specific competencies. And in this project, we're focusing on the technologies of the 3 Manufacturing USA institutes. So the student then sort of builds through and ends up with the skills needed to either move directly into a job as an advanced manufacturing technician, or to continue their education into an engineering pathway or other kind of pathways. So one of the things that, and Emily had showed the word cloud with the differentiators, very specifically one of the things that we think differentiates this curriculum from others that may be out there is the inclusion of material science as a foundational requirement for manufacturing education. And so our partners, as I mentioned, Ohio State University, PAST Foundation, in partnership with the ASM Materials Education Foundation, have created a foundational material science curriculum to start off the Ignite curriculum. So I am going to now introduce Carrie Wilson, who is the Executive Director of the ASM Material Science Foundation, to take us through that material science curriculum. Carrie?
Thanks, Eileen. First, I just wanted to let you all know that the ASM Materials Education Foundation is all about developing and deploying hands-on material science content for future generations. And it's an organization that's been the philanthropic arm of ASM International since the 1950s and providing educational programming since about 2000. So we've been in this space for a while and do feel like material science is an important part of this manufacturing curriculum to help students who are eventually going to be workers to understand the basis of any manufacturing process. They should understand why a material is being chosen to be used in the manufacturing process, as well as how the material is being treated and what happens when any of these processes take place. Without that basic understanding of materials, if you're working in a manufacturing environment, you're going to be just taking orders and not really be in a position to troubleshoot and to come up with solutions on your own because you don't understand the basics of what is happening in those processes. So we've found that material science is rarely part of a high school curriculum anymore. We're doing our part to change that and find that even in chemistry, where they're talking about properties and processes, they're usually focused on liquids and gases and not on solid materials. So the focus of this material science curriculum is on solids and talking about what their properties are and how different processes like heat and things like that will affect what those properties are. The Ignite first semester curriculum offers 4 material science modules that can be incorporated into an existing course. These modules were developed with the PAST Foundation and the Ohio State University working together, and provides first an introductory module for material science in general, and then we go on to a unit on polymers that has a shoe design challenge, a module on metals, which talks about lightweight and safer cars, and finally a module that is on ceramics and focuses on a house design challenge. So this offers students an introduction into what the different types of materials are, how their properties are important to consider when they're looking at a particular type of use, so they can see benefits and issues that may arise with each different type of material. In addition to the curriculum modules, this program is offering teacher professional development. Because material science is not something with which a lot of teachers are familiar, the ASM Foundation has been offering their materials camps for teachers, and this summer provided one right at the Learning Lab with LIFT, and that's a part of the Ignite program, and those teachers participating have been a part of that. So this is a week-long professional development session that provides the content knowledge as well as teaching methods for hands-on education for the material science. And then we also provide resources for teachers beyond that program throughout the year. So we focus on, as you can see here on the screen, making sure that everything's focused on real-world applications and that we're trying to provide things to do experiments in the most inexpensive way possible so that it's available to all teachers in all kinds of schools. So like we said, material science is a key to preparing students for any job in manufacturing. And we've had a lot of great success with students that are in career and technical education, as well as those students that are in a more academic college prep track. Those that are going directly into manufacturing gain a much better understanding of what it is they're participating in and what their job entails and issues that may arise in that space. And then the students who continue their education on into engineering careers have gained hands-on practical experience working with materials that in a lot of environments they might not get until much later in their undergraduate careers. So we consider this that material science is an important feature of this manufacturing core curriculum, and we're proud to be a part of it. So we'll pass it back to Eileen now.
Great, thank you, Carrie. So that's one really definitive differentiation for this Ignite curriculum is the inclusion of material science. The next graphic that is coming up on your screen is the overall curriculum pathway, which starts with this material science and then moves into, again, now translating from the education pathway to the curriculum pathway with the courses and learning outcomes. So to talk about this and to explain a little bit more about the details of the curriculum, I'd like to introduce Paul Perkins, who is the CEO of Amatrol in Jeffersonville, Indiana, and our key partner on this aspect of Ignite. Paul?
Okay, thank you, Eileen. The curriculum elements that Amatrol has been involved in on the project consist of 3 courses, and the first course is an introduction to advanced manufacturing, which is a semester-long course, so it's the second half of the first year that goes with the material science course that Carrie was talking about. And then there are 2 more courses that are each a year long, and they're manufacturing systems courses 1 and 2. So I'll talk about the introductory course first. It's designed to get students excited about advanced manufacturing by giving them hands-on experiences with a wide range of technologies used in advanced manufacturing. So as part of course 1, students are going to get to program a robot, program a CNC machine, draw parts with computer-aided design software, connect and operate electrical and pneumatic control circuits that have things like electronic sensors, and they're going to get to operate computer-controlled machines using touchscreen interfaces, which in industry are called HMIs. So they're going to get to do a lot of fun stuff, and in addition to the technologies they work with, they're also going to be learning about the processes and systems that manufacturers use, processes such as lean manufacturing, KPIs, key process indicators or manufacturing metrics, and also learning about the career ladder structure that exists in manufacturing. So our goal is to make them aware of the different types of career paths and why manufacturing really has a bright future in the United States and something that they should be considering as part of their career direction. So the length of time that the students are going to get to spend in each topic is very short. It's about 4 hours apiece because our objective is to give students a very, very broad exposure and hopefully have them connect with some key things that really interest them, and you don't always know what that's going to be until they see the full range of opportunities are there. The learning experience is actually going to be multimodal. The students are going to get a chance to do hands-on with real equipment and software. They're also going to be using an interactive multimedia curriculum that has simulations of the various activities that they'll be doing with the actual equipment. And then there's mini projects. And so the mini projects are individual student problem-solving activities where they get to apply technical skills that they've learned in the various lessons, and this is a more creative application. So that's what they will do in the second semester of the first year. And then going into the systems courses in years 2 and 3, the students are going to go deeper into technical topics, many of them things that they've seen in that introductory course, but going deeper and building on those skills. They will also be using a lot of the same tools, interactive multimedia, simulation, hands-on, mini projects. But there's 2 additional elements that we'll be blending into these courses. One is the integration of the material science activities that have been introduced in that first course. And so there will be a number of activities where the students are going to be learning about how material science impacts advanced manufacturing. And then the second major element is the students are going to be working in teams of 4 to 7 students on team-based projects. So they're going to design and build more complex projects that involve blending a variety of the technologies that they've worked with individually. They'll be doing things like designing and building an automated assembly work cell or a desalination machine. There's a whole variety of projects that they'll work with. And the students will have to research the project, develop multiple ideas, analyze and choose the best solution, and then fabricate a prototype and test its operation. So our experience has been with team-based projects is that they're not only engaging for students, but they reinforce the technologies that they've learned individually, and it has the benefit of helping them learn about some other important skills, such as how to work on teams and how to interact with other people and problem solving. And those are some of the employability skills that were talked about as the first part of the curriculum. And we've actually developed curriculum as a part of these courses that will blend those into the activities that they do with technology. The new projects that we're going to be developing for the courses will be theme specific to the 3 manufacturing institutes. So there will be a team-based project on digital manufacturing, one on lightweight materials, and a third one on additive manufacturing. The kinds of jobs that the students could get as a result of working in these areas include areas like going into production and maintenance and manufacturing, engineering, and certainly going on into the post-secondary. If you look at the next slide that will come up, it'll show you some examples of some of the multimedia screens and the experiences the students will have. And on the left-hand side, there's 2 screens that show essentially what you might see as a textbook part of multimedia. So it has text and graphics that teaches the concepts, and there are also animations and videos and narration. So it's a full interactive multimedia experience, and students can actually do things with those pages. They can start and stop circuits and change the operation or see an animation. And what we've also done is we've embedded simulations of the hands-on activities as a part of those, and that's what you see on the right-hand side of the screen are 2 examples of what we call virtual simulators. The one on top is an electrical simulator where the students actually hook up their own components just like they would do on a real piece of equipment, except they're doing it in a virtual environment, and it has all the same experiences and behaviors that they would see on the actual equipment. The one on the bottom is a CNC simulator, so they can actually program a CNC machine and see it cut parts in a virtual environment. And our experience has been is that students really reinforce their knowledge and their skills, and they're also very energized by having the opportunity to work in these simulations in addition to working with hands-on and working with the interactive multimedia. All the learning is competency-based, even in the introductory course, so the students are learning industry-relevant skills. and they can use that to go out and get into some entry-level opportunities in industry right out of high school. They also are learning a subset of the skills that could be used in certifications like NIMS and MSSC, and so there's some opportunities to actually validate that while they're in high school, as well as articulating that credit into the community college. And now I'll turn it back to Eileen.
Okay. Thank you, Paul. That was great. I did notice that and I'm going to just give the answer to everyone in case the question has come up. I thought I said it, but if I didn't, and perhaps you've deduced it by now, the Ignite is intended for high school. It's a 3-year program that our original thinking is probably grades 10, 11, and 12, but could start in the 9th grade, go 9, 10, 11. So apologies if that wasn't clear up front. So I would just want to give you sort of a sense of where we are on this pilot project, and then we'll wrap it up and see if anyone has any questions for Paul or Carrie or Emily or myself. This, as Emily described, the Department of Defense opportunity to do this pilot. The pilot will be an implementation in 3 high schools. That is our minimum. We hope to do more, but the 3 high schools, one aligned with each of the Manufacturing USA institutes, so one each in Detroit, Youngstown, and in the Chicago area. So as we're excited to say that our first high school started school last week, right after Labor Day, and that's Stevenson High School in the Detroit area. So they are our first pilot school that is kicking off now the material science segment of the curriculum, and are underway. So we're very excited to see things come to fruition. We're also working with a high school outside of the Chicago area, Waukegan High School, and then with the Youngstown City Schools, and hopefully we'll have pilots going there very soon. So that's essentially the gist of the pilot, although we certainly are interested in doing more. But that, I think, covers just about everything that we had on the agenda. But perhaps, so I think I will, I guess, turn it back to Joe and see if there are any questions or comments from folks on the line.
Thank you, Eileen, Paul, Carrie, and Emily. That was great. Again, if you do have a question, please use the chat function on the GoToMeeting taskbar there. You can address the question to everyone, or you can address the question to the administrator. We did have one that came in for Paul, which is wants to talk about how long the professional development is for faculty at Amatrol to get a sense of the Amatrol equipment and how it works with Ignite.
Thank you, Joe. There is teacher training involved, and so we offer a week of training for each of the courses, and the teachers get to come to the training and actually get hands-on with various devices, as well as work with the interactive multimedia, and then they learn about how to sequence the course. So it is a train the trainer from a standpoint of teaching the course, as well as actually knowing the technologies and materials being used.
Excellent. That are associated with this program. Schools are going to put this in their in their school calendar, and with their teaching, there may be some costs involved. Can you talk about that a little bit?
Are you directing that to me, Joe?
No, I think that was for Emily or Eileen.
Okay.
Big picture.
Sure. So this is Eileen. I'll jump in on that, and then Paul, if you want to add, we are so there is some equipment that is required. That's probably the most significant cost, but that depends upon obviously what the school might already have So that's not I can't give you a hard number, but if you're interested in learning a little more about that, I can provide the equipment list that will give you, I think, a good sense of what that ballpark might be. And that is really probably the primary cost for a school to implement, would be the equipment to go along with it. So we don't have a pricing package just yet for the curriculum, but we're working through some of that thinking now, and we'll be able to provide that hopefully not too far down the road. Emily, did you want to add anything to that?
I did. Thanks, Eileen and Paul. You did hit it with the pricing package being under consideration right now. I think the important things, though, for our audience to know is that undoubtedly costs are going to vary depending upon their choice of which of the modules versus the total they may select, number one, what materials they currently have in their school. The curriculum and the equipment list are quite adaptable to resources that are already available within a school, and that is something we would provide the technical assistance to assure there was full use of currently available curriculum, faculty, and equipment. The emphasis on the availability of some, if not all, equipment, I think, is something that Paul Perkins emphasized so articulately in his presentation, and that is this really is that blended learning of both virtual, online, and the opportunity to apply that knowledge on equipment that is very real-world focused. So we are all strong advocates for assuring that there is the opportunity for all students who are participating in this to use not only virtual curriculum, even that is replete with simulations, but also has integrated into it the project-based learning and the real-world application of the knowledge. So I think one of the differentiators, again, that I didn't emphasize at the front end of the program is the fact that this is an adaptable and flexible curriculum aligned to equipment that provides for the student the best possible experience and learning outcomes, taking into account the resources available to the student and the school. That has been really a product of over decades of experience and investment already made by our partner Amitral into this package. So thanks for the opportunity to supplement.
Thank you, Paul and Emily and Eileen, for that. So this is a pilot program, obviously launching at 3 different schools in 3 different states with 3 different Manufacturing USA institutes to start off. But if the school were interested in participating in this program in the future, what is the best direction to provide them to kind of get the ball rolling?
This is Eileen. I'll take that one. My email address is on the screen. I think if someone is interested in talking more about what that potential might be, if they would shoot me an email, we could set a time to chat about what that might look like.
Fantastic. So I please encourage you to take a note of these emails and reach out to these folks. They are the experts in what is happening with Ignite, as the pilot is just getting started, like we mentioned, just this past week in the Detroit area, as our schools just got started underway after Labor Day. Again, please, this webinar has been recorded and is being recorded. So if you please can take a look back at the lift.technology website under the workforce tab. All of our Bringing Mind to Market webinars are being posted there, so you can please review them there and share them with folks who may or may not have been able to to join the presentation, or if you wanted to take a look at them again to review anything that was said, that was said today. So another question that came in the meantime, are there any specific employers engaged who provided input in the curriculum as it's been developed, or made commitments to internships or future employments?
This is Eileen.
I was going to say,
yeah,
could you share the quote from the Chicago employers?
I think I can, yes. I was just thinking that. And what Emily is referring to is our, and I think some of our potential Chicago partners are on the line. They've been doing their due diligence as they've been thinking through partnering with us on this project, and their economic development partners in the Chicago area have been talking with employers. And if I could be super quick and spiffy,
I found it.
I've got it also. Yeah, I've got it. we are on it. So this is a meeting of with the economic development partners in that Chicago area community, with employers in the area, and I'm quoting the email. Says, first, we had unanimous endorsement of the curriculum from the several local manufacturers that we asked to preview it. Each was enthusiastic about the technical focus, the great mix of hard and soft skills, and the opportunity to hire graduates from this program. There's no question that there is a high demand for the technicians this program would create. The data show we will have over 600 related openings a year through 2025. And that's actually outside of Chicago. That's not a Chicago data point, so that number would be much more. But that was very encouraging, obviously, to us. The employers are very interested in these skills and competencies and are anxious to be involved. And we do want to, we talked about this a bit in a couple of the meetings we've had with the Manufacturing Institute partners. We want to create work and learn opportunities for students, summer internships, other ways beyond what Paul described in the curriculum to get their hands on the equipment and really understand what the jobs will be like. So that's a very important factor, and employers are anxious to be involved.
And Joe, this is Emily. Since we have a couple of minutes here, the other point I would like to make that is, has been mentioned and clearly related, I encourage everyone on the phone that is not familiar with the ASM Materials Science Teacher Boot Camp that Carrie spoke to us about. As she said, we conducted our first boot camp in Detroit at LIFT, July 9th through 13th. Actually, members of our curriculum team went to boot camp at the University of Michigan in Ann Arbor a year ago. And the professional development for teachers coming out of math and science and history and English, because there is no material science courses in most of their high schools. But those teachers coming to the boot camp, which is all hands-on and wholly integrated introduction to advanced manufacturing, and then working in teams throughout the week, is one of the most gratifying educational experiences I've ever had. The quality of the master teachers is extraordinary. Carrie will probably correct the numbers for me, but they are now in some 22 states, I believe. LIFT actually introduced ASM Material Science Teacher Boot Camps with ASM in Tennessee, and then they invested the subsequent year because it was so beneficial for their teachers. There are just so many good stories about the professional development opportunity for teachers. And I encourage all of you to consider looking at the closest available opportunity, and where there might not be one, consider with Carrie and our project team where it might be most useful to assure that in the future our educators have this opportunity. So I just certainly want to encourage you to do that. And I see one of our audience members indicated he concurred, and he was part of it. Oh, you were at the boot camp at LIFT, and you had a great you had great teachers attending, and we know that. So thanks, Tom, for bringing that up.
Thank you, Emily, and thank you, Tom, for your participation and your comment. A quick question about the time frame regarding this the Ignite program. I know we said it focused and really was kind of geared initially towards grades 10 through 12, but could be delivered in grades 9 through 11. Could it be delivered in 2 years, or is it that malleable and moldable or modifiable, or is there a way to do it in 2 years or 3?
Sure. In fact, the material science portion can be integrated into multiple gen ed courses, or as Paul indicated, wrapped even more so into the 2-year advanced manufacturing curriculum, so that that's not a separate timed event. And there, I can't stress the flexibility and agility that Amatrol has built into this. So it's a work with schools in what they have the capacity and the time to do.
Excellent. Thank you very much. Again, if you have additional questions after the webinar, once you watch it again or share it with your friends and family, please reach out to the folks, Paul and Carrie and Eileen. Their emails are on the screen. You can reach out to them, and they'd be happy to answer any questions you have regarding this. So we are looking forward to getting this really underway, as it just got started last week, and see how it rolls out here in the Detroit area, and then follows up with schools in Ohio and Illinois. Looks like that might be all the questions we have for now. So please, again, reach out to those folks on your screen. Reach out to Lift at lift.technology, and we look forward to you joining us on our next Bringing Mind to Market webinar in October. So thank you very much for joining us today, and we will talk to you next time.